And we're back with Michael Baddley. How the devil are you, sir?
I am incredibly well, Sam. Very, very well. How are you doing? Anyway, more importantly.
Look what I've got. Look at this sucker.
Good God. Look at the size of that.
Look at that one. Yeah, it's really, you know what? It's really satisfying to kind of get from the treads, which, you know, it took a significant amount of time to print these. Sometimes they were printed one at a time. Sometimes, and then we got on to sort of doing 10 at a time. It's TPU, PolyMaker TPU95 on this one. And it's quite satisfying actually putting these things on and actually having this running. You know, we've got the motor inside. It's got the planetary gearbox in there. We've got a little bit of polycarbonate, which is I've used on the gearing just because I wanted that extra strength. I know we probably didn't need it, but you know what I'm like. I like to break stuff. Yeah. So we're at a point now where this is running. The electronics are here, and I'm obviously going to be putting this into some kind of frame. And off camera as well, I know we've been kind of working on a few other bits, but I've also got a TPU wheel as well. Now, this was PolyMaker TPU90, so I've gone slightly lighter on this one, but I did put a little bit more infill onto this. I've still got to screw it together and stuff. The element that you sent me, which is this particular part, which I guess kind of bolts on this way somehow. Unfortunately, I had a bit of layer shift on that, which is bad news. Okay. This print is about 750 grams. So, you know, I've essentially wasted almost a kilo of filament on that one, annoyingly. But I've got another one on the print at the moment. So we are whizzing away on that one. But obviously, I'm keen to get onto the next part. I want to bolt these big wheels onto, or big tracks even, onto some kind of solid frame. So could you go through what the next steps are going to be for this particular droid?
Yeah, absolutely. How's it running though? First of all, the drive.
Oh, you know what? Really nicely. And I got where is it? I got this lovely tub of grease from Amazon.
Nice.
And you know what? It's really, really good. And I haven't I've greased the internals of the gearbox. When I was greasing that up, that's absolutely fine. No issues at all. It's not silent, but it's also not particularly loud either. And the other part that I haven't done yet is where the almost triangular gearing goes on and connects to the inner wheel. I haven't greased that up yet, but I'm assuming...
Okay, the bevel gear.
Yeah, so do I assume that I've got to do that as well? Or is that a little bit... Yeah, wax them in there?
Put some grease on there, yeah. It runs really smoothly. It's a lovely drive. And
it is.
There's a lot of torque in it, a lot of torque.
Yeah, it's exciting because I really want to get this finished and done and get it moving around. And it's almost kind of at that point, with R2, when you get R2 moving for the very first time, because this has not been done before and it's kind of exclusive to us right now. I'm at that point where it's very, very exciting again.
So I've got the caster. So when you built the caster, this is what it'll kind of look like.
Yep.
So again, I mean, it's a really strong build, as you can probably feel from yours, but you've got this other piece here which goes onto, which then this bolts onto that leg that you've got. And yeah, they're a nice run. What is it 95 using, did you say, on the TPU?
This one's 90 actually, but
90, okay.
I think I put about 20% on it, and it has made it like it's really, really strong.
Brilliant.
I did another test print as well, and I'll show you. I'll actually just grab that. So I used TPU95, and this was 20% on this particular one, and it's nice and strong, like you'd expect a tire to be. I didn't want too much flex in it, but I did also print this in 10%, and you can really see on this one that it's got that real bend and flexibility to it as well. But what I found is when I was printing it, and I don't know if you can see. Can you see that little gap?
Oh yeah.
So that's on one of the Z lines there. I think because in fact, there's a couple of them actually as you go around here. You see these little bits here? Yeah. And I think that's because it was a little bit too hollow, especially on that particular angle. So I changed it up. I've printed the new one on the RatRig. This was done on the BQBX. I know I just wanted it to print and not to have any kind of issues. So I figured the RatRig was probably going to be the better way of doing it. But, I'm going to try both tires, I think, even though it's got that little bit of, undulation on there. I don't really want to be representing PolyMaker with, a inferior tire. So, but it's cool. And I can see, I don't know if you've ever printed a phone case or anything like that with TPU.
Right, yeah.
I haven't, but it's something I kind of like to try because it's it's an interesting format. And
the TPU is fantastic. It's brilliant.
Oh, it is. Yes,
these are the ones I use in these smaller track droids, and they're this has probably done about 2-3 days worth of running on concrete, and there's nothing on it. It's not even marked. It just lasts. They're and like you said, the 95 is quite good because you don't want it too flexible. You want it fairly solid, particularly on track. So yeah, really impressive. Anyhow, so you've got 2 drives. You've got a back wheel. You need something to pull it all together, don't you?
I do. And ideally, what I'd like to do is put a 12-volt, 16 amp per hour tracer battery in there. So this is a Life PO4 battery. So they're super, super light. I'm hoping that it's going to kind of squeeze in there and we're not going to have too many problems with the fitting. But obviously scaling up this Tito is, thank you again for, being involved with this and getting this done, because I was super keen to make something that was more unique for the TCT show. And of course, this is going to be running around at that show. And, I just wanted something that wasn't going to be an R2D2, that was going to be something a little bit more unique. And I'm keen to obviously get your ideas around how this head movement's going to work. The other thing is I bought a load of...
25 kilo servos.
I bought the 25 kilo servos, which are here. And I've also bought some orange... I'm excited now. A couple of things that I bought are a couple of orange receivers as well, so I can use my DX9 on this.
Brilliant.
DX9. Also, Cytron do a smart drive 30 amp unit here, which I know it's probably a little bit overkill for the bits and pieces that I guess we normally make, but this is a 30 amp radio controlled receiver that does tank drive. So it's a bit like it's a bit like a Sabertooth, but
that's Cytron.
Yeah, and I hadn't seen it before, but it does, as you can see here. There's the little remote control here.
Oh my God, Sam Prentice. That's brilliant.
Don't tell anyone. Don't do another one of those Moteps, for goodness sake. But this is called the MDD-S30. So, if you are interested in setting one of these up, and I think from memory, it was about 30 quid. So
wow.
And
£28, 15 pence of your English.
And if you look here, you can put up to 35. It's 7 volts to 35 volts. And it also has a microcontroller part here, and I believe you can put servos on it.
I want that now. That's going to be my new favourite
toy. I
have
told anybody about this. I should have just remained quiet. If I
you should have done.
I didn't even know about the microcontroller bit there. But
I've got a sandcrawler that needs one of those.
But yeah, steering on channel 1 and channel 2. It's ready. It's RC, because a lot of these Cytron ones, they're normally
Arduino only.
PWM, programming. So to see this and to find this that does radio control parts, MDD S30 Cytron Smart Drive Duo.
I am going to buy a couple of those to play with. Yeah, because I run the DO runs on the MDD 10 amp, which is but again, every one that I've seen on the Cytron ones have been Arduino or serial control, not using standard PWM from RC. So that is such a good find. I need to buy some.
I've been looking. I do really rate the Cytron stuff, even if you buy it from abroad. It's Malaysia, I think. But I got this from it. I'll find out and I'll put it in the link, or I'll ping it to you a little bit later on. But there was a UK supplier that I got this from, and I can't remember off the top of my head who it was, but I can certainly Google it. But yeah, so that was super exciting. So I've got all the gear, but yet I've got no idea.
They've got them in RoboShop, but anyway.
Yeah, I don't like using RoboShop. I had a bad experience with them once, and I just won't use them again. I'm sorry to say, but that's just the way it goes. But no, it's got 80 amp at a peak, 30 amp continuous on each channel, onboard MOSFETs, switch to 18 kilohertz for quiet operation, battery low voltage indicator as well. Now, the funny thing is I did go on the website and I was like, does this work? Because like you said, the DO obviously runs off an Arduino. And ironically, when I was doing the Droid Builder series, also on YouTube, I found in a cupboard, I bought a load of those motors thinking, oh yeah, one day I'll just whack an RC unit on it, of course, but it doesn't work. So it was really refreshing to find this particular unit. And you know, I'm hoping it's going to work and be awesome and brilliant and all the rest of it. So
well, they're out of stock at the moment. It looks like
they are out of stock at the moment. So hopefully they'll be back in stock at some point. I kind of felt like I might have bought. No, I only bought one. I was going to buy two because I thought maybe people would then sort of try and jump on this. But it is what it is. If you can get a hold of one, great.
I will. I'll put them in the instructions on the Sandcrawler. That'll help with the stock.
That'll help everybody. Not. But yeah, I mean, you know, I think it's a very good. I think, you know, 100. I think a Sabertooth is 127 quid there or thereabouts. I think from memory, and I'm not saying it's a bad thing, but when you're trying to build essentially a cheap robot, you know, those parts that you don't even see, you know, it's a lot of money. Same with those the motors that went into this as well. I think I picked them up for £7 or £8 on eBay. Oh, sorry, on Amazon, and then I put a link on your site, and then they are up to 35, 36 quid each, which, you know, is terrible, really. So, you know, getting a good deal on these things are, you know.
I just drop them onto eBay. They come off on eBay quite a lot, those motors. So I just keep buying them when they're there. Quid away. So cool. Anyhow, should we jump into CAD? I think. Let me share some screen. Okay, so this is where we are at with the CAD. So obviously you've now built the drive on both sides, and you've got to imagine it's got another leg. The leg that you've printed that's got the layer shift is this one at the back. And you've got this frame which is also in there to print. So that's what I've just showed you before. And that bolts in with 4 bolts at the bottom onto the leg, and the leg bolts into this main frame with 4 bolts here. So what we've got is we've got this body frame. Now, you mentioned putting a 12-volt battery. Here's one I prepared earlier. So actually, it perfectly fits a 12-volt battery in there. It can drop in and rest on this bar. This is 2020 aluminium extrusion that runs right the way through.
That presumably then is where this little hole is in here. That's where that 2020 is going to go into, right?
That's right. Yeah. So the 2020 goes through that hole. It'll go right the way through, and then there's these little brackets that actually go on. I think you've got the 2 tabs on yours as well, haven't you? These 2 ones that stick out. Yeah. So those 2 tabs fit through that hole. Your 2020 goes right the way through. The bottom tab bolts in with probably slightly too many screws, but you can never have too many bolts. And then the top one, you've got a bracket that goes over it like that. And that effectively holds this on. The power cable goes through that hole there. There's a couple of holes for cable ties. And then the cable will come through into the main body here.
Christ, Mike, what have you been drinking? That's not the gin in there again, is it?
No, it's that special lemon water that we always like. So yeah, so that's your cable harness. Cable goes through to there. I've got a real frog.
Finish the CAD before you die.
I know, it's okay. We're nearly there. You've got the files. It's all right. We can recreate it. Yeah, so two brackets. This is main base. Now, the exciting thing about this time, of course, is you're only 3 prints away from actually having something that can roll around.
I know. How cool is that?
Because you've just got this box. These 2 brackets. Get that connected up and get that running. Then...
How long is that extrusion?
This extrusion here...
Yeah.
It's about 500, I think.
The reason I ask is because I actually feel that perhaps I've got an old CR10 S5 that, you know what, it might be redundant now, but maybe there's parts of that frame that could be reused. So it's got Creality inside, maybe, worryingly enough. But yeah, I mean, I think that would suffice with that. And how does, so internally of the track bit, there's nothing that holds that in other than the fact that it's stuck there because it's, how does it not come off? Do you know what I mean?
Yeah, so
okay, right.
The 2020 extrusion goes into these slots here. So you'll have a couple of T-nuts that go inside, that slide inside 2020.
Gotcha.
And then a couple of 4 mil bolts that will go through there. So once you tighten those, it'll, as you know, with extrusion, it'll pull the extrusion into the plastic, which means that won't come out, be solid.
Great.
So that'll hold that bit solid. But as well as that extrusion going, you've also got these two the two plastic brackets. So between those, that'll give you a huge amount of strength in that area. And then there's a series of 5 holes here that actually bolt through this face into the main frame. So you've got it locked in at the hub of that top drive, and you've also got those 4 bolts in. So it's actually, because that's a bit like R2, the weakest point is always the shoulder. So that's going to be the weak point. That's why we've got to make sure that there's plenty of solid connections on there.
Gotcha.
Then you've got battery, and then loads of space in there for speed controllers, electronics, and all of that kind of stuff.
Brilliant.
Yeah.
Sounds brilliant. Yeah.
And then, which I've been messing around with today, if I can find which we've got the. So as with the other one, you'll have this main cover that will go over there, which will cover everything.
Yep.
And then you mentioned before about the neck mechanism.
Yes.
So this is the start of it. So what you actually got is you'll have, this is a 100mm circle, which will the whole net will turn around probably 180, so you can go from looking across one shoulder to looking across the other shoulder, because them 25 gram servos are 180 degrees.
Yep.
So that'll turn the head, and then there'll be a couple of bars on the side that hold onto these 2 bearings, which will give you a nod rotation.
Yep.
And then there's 2 more bearings here and here that will give a tilt rotation. Yep. So between those 3, you should be able to nod, sort of tilt, and turn the head.
Gotcha.
And what I'm thinking of on the head tilts is, once I've got there'll be a couple of plates that come from the neck and hold these 2 side bearings on, and then your main head plate will run off these 2, off this angle bearings here.
Amazing.
And then what I'll do is I'll probably put 2 servos at the back of the neck like that, with little servo arms out that connect to that plate. So if you can imagine, they both go together, it'll lift its head up. If they go down, it'll lift its head down. But then you can also do all of the head tilt and the turn.
Gotcha.
So you should have quite a lot of expression. The only challenge with that is finding how you map that onto the RC, because a bit like BB-8, where they put a gimbal on top of the controller.
Yes.
Because you've actually got 3 axes there. If you've got a head turn, you've got a head nod, and you've got a tilt. Whereas on your traditional stick, you've only got 2 axes. So you can either use one of the little pot dials to do either head turn, or you can attack. They do modifications, don't they, where they put gimbals on the end. But
yeah, I mean, like I said, I think on the controller that I'm going to use, I have got a pot that I was just going to be able to turn. So how that kind of works in your hand is up for debate a little bit. But it's one of those, that sideways motion, that emotion that I'm looking to try and recreate there. I think that is something that's maybe a little bit more, what's the best word for it? It's also almost bespoke, because normally when you're talking to people, you're sort of talking away like this. But if someone says something to you that's a bit curious, you might be like, I can kind of see where that comes from. And that's where, actually that one single movement to turn that and then to turn it the other way, that's kind of where I'd want to get that motion from. But how that translates onto servos, well, that's up for debate. And like I say, we shall see kind of how that kind of comes about. Now, I'm actually, with this controller, now that I've seen a few more things, because I haven't even opened the box until now, I'm just wondering if this microcontroller, because you've got 2 outs there, you've got 2 outs, you've got a ground, you've got a NC, and you've got a bunch of other stuff there. So I'm assuming that you're going to be able to put power into this. So there could be, perhaps not for this particular model, but in the future, there could be buy one of these and run a ton of other stuff off of one particular sensor, which could actually be really, really interesting. But we'll wait and see on how that goes together. But, with regards to power, and, we've had this in the past with the smaller baby R2s and things like that, you do get an element of twitching. So, and a lot of that's down to how clean the signal is from the receiver into the servo, and also power fluctuations as well. So how do you think this is going to work? Will I use like a 5-volt or 10-volt? Because they're 7.2 volts, these servos, right? So
yeah, they are.
And what? I'm going to put probably about 3 amp into that or less.
I'm not sure what they're rated at, but what the way that I'd probably do it is run each one off a separate UBEC. So you can get you've got your main 12 volts that'll power, and then off the 12 volts you run some UBECs, and you can get 3 amp 6-volt UBECs. 6 volts will probably give you lots and lots of torque on those servos, and so what you could do is run each one off a UBEC. What I wouldn't do is run them off obviously off the any UBEC that's built into speed controllers, because there's been nowhere near enough amps to pull those, and then you'll get twitching and you'll get all of that sort of stuff. The biggest problem that's what causes on a lot of the smaller ones is if you try to run everything off the speed controller 5 volts, you drag the voltage down, it resets the speed controller, which then resets the RC, and then you start getting beeping and all sorts of stuff.
Sure. Yeah, that makes sense. That makes
sense. And most
well,
batteries will happily feed out of the 12 volts enough to support everything, really.
Yeah, I mean, obviously this is we're cutting it quite close to the line here, with the show being literally a month and a week or so away. Are you going to TCT?
Yes.
Are you there for 3 days? Are you staying up there? What's the deal?
I don't know at this stage. I've not quite decided. I've got enough holidays booked to be able to take the 3 days off if I want to.
I guess we'll be meeting back in about 10 days or so, and I should have all this stuff hopefully put together, and we will continue forward. What are your thoughts on this head? Is this head going to be ultra light because it's going to need to be because of the servos, or what do you think?
The 25 kilo servos are pretty strong, and the mechanism that I'm using is effectively using 2 rods. So there's a rod on each chin that will go like that. So you've actually got 2 servos that are holding the head up. So there's quite a lot of strength in there. You still want it to be as...
I'd like to see a Michael Baddeley head whizzing around.
That's how it works. Yeah, we are all 3D printed in this world. No, but it is in theory the 25k ones will be strong enough. But obviously, I'm not looking at, if I can get away with 2 mil thick walls, then that'd be great, because the less weight that's in there. The problem with Tino is it is a big head. It's a big old chunky head, and even on the small one, you've got the slightly stronger whatever they are, the 92B servos beefed up a little bit to turn it in certain ways. So you'll have the same issue with that on that side. And of course, it depends what lights and things you want to put on it as well. So
absolutely. Well, obviously the point, I guess, is going to be go as light as I possibly can do. I don't want to put too much strain on it. And I guess as well, you're going to have that kind of, you kill the power and it's going to drop its head down again, is it? Or are those servos a fixed servo, or
it will flop if you turn the power off? It depends on the balance. I can have a look to see if we can get the balance a little bit better.
Yeah, it might be interesting. It might be interesting. How big is that head going to be, as in size wise? Have you put any thought into that yet? What's the scale? If it's scaled at the moment, what's that scaled by?
Yeah, it's probably a 400. I'll get away with.
Okay.
I think you'll fit it on a 400 bed, if I'm honest.
Okay.
If I jump, I can quickly just show you the CAD again. So there we go. So yes, if you look at this, this line across here is 495. So and I've not drawn the head yet, but if I was to say draw a 400 wide head, it's that big.
Okay.
So a 400 wide head is probably not far off. In fact, to be honest, you might do 380 by about 150. That'd be about the size, I think.
Cool.
And then do about the same depth, so probably about 380 by 380.
Great. Okay. Yeah. I mean, like I say, balance is going to be something that's going to be quite interesting on this one. And I'm almost thinking, like, what they do when they balance cars with the wheels, with the tires. It might be worth putting a couple of little bits of lead shot on there, just to kind of make sure that it's an interesting point what you said there, because I'd rather the servos be doing the work to go up and down, a bit like a gimbal, that kind of thing. Very interesting. Very interesting. Okay, mate. Well, listen, thank you very much for your time. And,
no problem.
I'll see you in a week or so.
Indeed, fantastic. I will look forward to seeing it roll around the first time it's ever rolled. It'll be fantastic.
Woohoo! Good stuff. Thank you, Mike. Appreciate your time.
No problem at all.